Here it is. So, yesterday I had some logistics problem. Even today there was a party nearby, so I was not sure even if I was going to do it. But here we are. So let's start. So today we'll just cover the MATLAB basics and so some kind of examples. So first things first. So MATLAB is a programming language, and so it has its own syntax and software suite. So it has its own libraries, and it's mainly used in data analysis, scientific computing, and visualizations. It's also widely used in academia and industry. So I'm sharing my screen. So I think you can see three parts: the current folder on the left, something called command window in the middle, and you have the workspace on the right. So basically, if we start with the command window, this is basically like a powerful calculator. So I can just go ahead and make 5 plus 5, and then you just hit enter to run that command, and it pops up to you the answer 10. So you also may notice that on the right side there is a new line that appeared, answer and the value. So basically MATLAB uses kind of built-in variable to save the result of your command. And basically I can call it back again, and it gives me. So you can also, I can also change it. So I can make it, I don't know, 20, and it changes here, and it changes also in the workspace. That's the basic idea, I guess. You can also add to it some numbers, multiply it. Yeah, you can do all these calculations. One thing also that we will see that this variable can actually be explored through an Excel version, like an Excel view. So when this variable becomes like a matrix or something, then you can explore it like in Excel format. And just close it from here, go back. Okay, so I can also assign new variables like x equal 10, y equal 20, and make z the sum of both. Yeah. Of course, when the screen is a bit like full with many commands, there is a shortcut like CLC to basically remove the history commands. So all these commands got run, but I'm just removing their the history. So, but I still have the Z, and you can see it here as well. Also, there's a command to clear the variables from the workspace to empty all these workspace variables. So, for example, I can say clear vars, and basically that removes all the variables. So if I call x, it doesn't know it anymore because its value got removed. Okay. One thing also that may be useful, you can use the upper arrow to access kind of your previous commands, and you can even star some. So I think you can, there's a star here, you can star some favorite commands to just become handy if you have a lot of like big equations or something, or big functions. So you can also, if you made like x equal and you press up, it basically becomes like a search in the history with x equal. What else? I'm just making sure that I said everything I want to say. Okay, the next page. Another way also to know the variables that got defined is using the command who. So let's, for example, have some, and you can press basically whos, and whos basically shows you the table the name of the variable, their size, and other like attributes. And this becomes handy, for example, if you have like a vector. I will show you this later, but just to show it here, I made a vector from 1 to 10. And if I press fuse again, it tells me that Z that I defined from 1 to 10, its size is 1 times 10. So basically 1 row, 10 columns. And you can also see it from the workspace here. You can see it here 10, or even you can explore it. You can see the 10 values here. Yeah. Okay. So what if I want actually to have some strings? I press CLC, just remove the commands. For example, if I say I want to have hello there. So here's a MATLAB recognizes text, so I don't need to define that this X is not a number. It recognizes itself by these apostrophes on the right or on the left. And if we want to know its type, we can, for example, press fuse again. And now X is size of 5, the 5 letters, and the class basically is a type of the variable's character. But for Y is and Z is double. It's a number. Okay. But this is most of the functions that has to do with the text is actually with another variable type. It's called string, and this one is just double apostrophes on the left and the right. And I made it. And now if I compare, here the size is different, you see, and the size in bytes is even bigger, but the class is string, here is character. So they are different, yeah. And so basically character, string, and double covers most of what you need for a basic MATLAB use. Okay. Also my voice is a bit thick. So now when I press, I don't know, like x equal 10, I don't know, I can't say plus y, but yeah, 50, whatever. And I don't want to, if I remove this semicolon, it shows the answer. But if I don't want it, I want to suppress it, I just can put semicolon there and it doesn't show me the output. The x got changed. If I call it out, it becomes 60, but it doesn't just automatically output for me. That's maybe important if you're defining a big matrix or a big vector. You don't want all that 1,000 outputs, 1,000 values to come to your screen. Okay. You can also, there's something like you can add to the number itself. So here it makes the x, it takes the 60 plus 100 and saves it back to the x. So I will like this, and it becomes again. I pressed it, or I didn't press it. So here x equal x plus 100, then it's 160. And you see it even changed in the workspace. Yeah, this is just all trivials. Just go ahead and move to the next point. Now, if I want to have CLC, if I can have more than one command in one line. For example, x equal 5, y equal 10, y equal 10, you know. So I have two commands in one line, and I just hit run, and they run after each other. X equal 5 first, and then y equal 10. Of course, I can suppress both of them. So I can make semicolon after y equal 10, semicolon after x equal 5. Okay. And basically, you can do all the algebra, the x plus y, the x times y. the division, and the power, and so on. Yeah, you have also built-in functions for like square root, round answer. You can take the sine of 2 pi, for example. So this is basically because of course pi here is not it's not like infinitely accurate. So here this is e to the minus 16, so it's basically a 0, right? Sine 2 pi is 0. And also you can make it in degrees. Sine here with a d. And you can put here 180, and then it becomes 0. Okay. So if I just have a quick tour in the toolbar, basically you can have new script, you can open files from your folder, you can import data, you can change your preferences from here. So it's all about open, save, and import kind of. For example, this one, you can change your background. So if I have this command window, I think it's in color. Yeah. So if you prefer something like this, then you apply it. I'm not used to that, but you can play with all like the keywords, colors, the strings, the command, and you have here like a preview. Not used to that, so I'll just bring it back. Okay. Okay. Basically, instead of running like this line by line, we can just run everything in a file. So we have kind of called script. You have new, and then you open a script. It opens this file. So here I can write what I wrote before, x equal 10. It doesn't run until I run the line or I run the file. It's just there. So the majority of actually all the programming that you will do will be in scripts. And you can do multiple lines without running them. If you want to run them, you can either press like the run one, or you can basically select and use F9. Run them here. They got run down there. Of course, if you don't want to suppress the output again, like this, you can select them. You press F9, they got run there. And you can see the value change in the workspace. You can normally people like start with clearing the command line, CLC, and the clear variables. Sorry, my laptop is a bit stuck. Interesting. Just got stuck here. Until it comes back. So also you can use the run from here to run, but it will ask you to save the file first. So hopefully it will let us. Interesting, I don't have so many things open. Yeah, I think it returned. Now running. Okay, so you can use the run button. Yeah, or you use F5. I think F5, but it will ask you first to saves a file, and it will save it in the current folder, the one on the left. And basically, you can call it two, and it's important that have this .m after it, otherwise you cannot call it again. So if I did not use it and I press save, so yeah, it makes me all this problem. Yeah. So, and you see here, this two is basically does not have the icons in MATLAB. So you basically maybe rename it. It comes back. Yeah. Okay. We'll go to the next thing is deal a bit with vectors and matrices. So the main difference between a vector and a matrix is basically vector has one of the dimensions, one of the two dimensions as one. So as an example, you can say x equal 1 to 10. This basically give me a vector from 1 to 10. I can just press it, and I can select it with F9, and it got there. Yeah. And if I check its size, I can check its size like this, size X. I press F9, give me that it is 1 row, 10 columns. Basically, if you explored it in Excel, it is the same. Excel format. You have the 1 row and you have the 10 columns. Yeah. What is also important is actually the comments. So the comment you use percent sign. So this is comment, and this is not run by MATLAB. It will not make a problem, right? And comments are important, of course, to make your code readable and to even make myself remember what I wrote before. After some time, I may forget what did I do. Okay. So back again for the vectors. So we saw like the x was like just one line like this. But if I want it actually to be like one column, I make like this. So here you have like 10 rows, one column. So I use this transpose. Okay. And if I made this actually, that is y. I run this. I press whose. You can see here x is 1 times 10, but y is 10 times 1, right? And in MATLAB, everything is actually stored as a matrix. So even if you have like z equal 1 or something, and you press whose again. So this is 1 by 1. So it treats it like as an array or as a matrix, but it's both dimension as well. Okay. And just for this function, this has this kind of column. If you put, for example, this, see, I want to go from 1 to 10, but with a different step. I don't want to go with step 1. I want to go with a step 2. So that does the job. Okay. Go to the next. Another way also to produce vectors is use this function called linspace. Let's make it here. It's called linspace. Yeah. And linspace is a built-in function that, for example, I want, if I made like this from 1 to 10, this would basically generate 100 values between 1 and 10. And these 100 values are evenly spaced. So you have a column until 100, so you have 100 values, but they're evenly spaced from 1 to 10. If I actually only want 10 values, I can just use a different parameter here. That gave me like previous command with the column. So MATLAB has many functions, of course, and one actually do not memorize. I always search when I forget something, and one does not need actually to remember all the function as long as you know what you need to do and you know how to get the information. So the functions in MATLAB, it takes arguments, these ones in bracket, or inputs between the parentheses, and each argument is separated by a comma, right? And MATLAB doesn't care about space if you made it like any spaces or something like that. It will still do the same job. When you don't know like how you need to know more about this function, you can use, for example, use help in space, and it gives you a very kind of short summary of what this function does and what the parameters that does it take. So it takes x1, x2, and n, yeah, and it basically gives a row vector of 100 linearly equally spaced. That is 100 is basically the built-in parameter. You can also use doc linspace, and that basically give you open to the other screen. I'll just get it in a minute. So basically give you this kind of online documentation from MATLAB, and much neater, yeah. It have examples and so on. It was very, very helpful. What else? I think and also another way you can just right click and help on, or you just press F1. And again, F1 opens the docs, yeah. Okay, let's clear this up. Another way also to define vectors, arrays, and matrices. For example, I want to make X have these 10 numbers, so I have this kind of square brackets. I can put the numbers inside, yeah, whatever numbers I want. And basically it recognizes them. And it doesn't matter, you can also separate them by comma, but it's all the same like space, so you actually don't need to. But now if I made something like with a semicolon, so this will generate like the one we saw before, like when you transpose the row vector becomes a column vector with a semicolon. Now basically because now you know how to make them in one row, know how to make them in one line, then you can start to make a matrix. For example, I can make matrix generally in big letter, like 1 and 2 in the first row, and then maybe 3 and 4 in the second row. After the semicolon, it gives a new line. So you had 1 and 2 in one line, and then 3 or 4 in the second line. Okay. That's how you manually make the array or a matrix or a vector. So next page. So again, you can actually deal with a matrix, like you can add to the matrix. So for example, you can add 10 to the matrix, and that what means it will add to every element. So it's element-wise process. So it will add to every element 10. Of course, you can do all the other stuff, times and so on. And but if, for example, if you tried something like that, you want to take square. This is fine, but if you want something, we have a different matrix, like 1, 2, 3, 4, 5, 6. Yeah, so another matrix. So I need like 2 times 3, 2 rows times 3 columns. If I made it a square, it gives me an error because now you have this is kind of linear algebra. So this one does not take every element in the matrix and make it square. It basically try to multiply two matrices. But now if you want only the element-wise powered, as he say, you can use this dot before this caret symbol. And that makes square for every element. Okay. Another, of course, you can make like a compound expression, which means like big equations of a. So you say, I want a square, and I want to add to it, or divide by, I don't know, 5, and I want to add to it 10. So as long as you are doing this element here, I don't need actually the element. As long as you're doing taking care of the linear algebra, will be fine. So you can do these compound expressions involving a matrix. There's handy ways actually of making fast matrices. For example, you want vector of all ones. So you say ones, and you say, I want a vector of vectors. I want 1 row and 10 columns. So it gives you 10 ones. And if you only put 10, it will consider like this is 10 by 10. So it will give you 10 by 10 matrix. Of course, you can choose 5 times 10 or something, a rectangular matrix. This also can be done with zeros. So you can do the same, but instead of ones, we have zeros. And you can even like have this identity matrix. So this is kind of I3. This is where the diagonals are having 1. Okay, so what else can we do? We can now maybe extract. We have a matrix and we want to extract from it a row or a column. So for example, let's have our previous A. I just press up and I went there and I press enter, so it ran the command, previous command. And now let's say, for example, I want to extract the first row. And the way to do it is you say A, you have this parentheses. You say I want the first row, make a comma, then I want every element in the first row. So you put this column. And that gave you the first row. Now, if you want the first column, you just do the opposite. So here, this is 1. This is the first column. Of course, if you want only one element, like you want this, maybe this 5. So you say this is second row, second row and the second column. That gives you the 5. And MATLAB uses something called one indexing. If someone is familiar with Python or something, they have 0 indexing. So the first index, the first address of the element is at 0. But in MATLAB it starts from 1. So if here actually I try to use 0, it will throw me an error. Okay. So there's also a way, for example, maybe I have a big matrix and I don't know how I want to go to the last index of it. So let's say, for example, I have is 100 to 100. This is column. And I want to take this 109. For example, you can say A, or let's take the end first, 110. You can just press end, right end, and that will, this is the index of the last number. And you can actually go back from it. So we say end minus 1. That will catch 109. Okay, so this is about indexing. And of course, you can assign. We have again back this matrix. If I want to change one number, like this 5 to 10, and say A equals 2 by 2, basically make it 10, and it changes that 5 to 10. So I can assign a new an element of the array of the matrix to a new number, or I can make maybe the first row all zeros. So you can say first row, you can use the zeros, and we want basically 1 row, 3 columns. Then we replace the first row with zeros. Okay. Okay, we can start with can have a problem maybe to try to solve. So the problem is basically we try to get the maximum value of the following equation. So the equation is y equal negative x minus 3 square plus 10. And he wants this maximum on a certain range of x's. So in a range of that x between 0 and 5. Okay, so let's try to write this. So first, to get a range from 0 and 5 for x, you can use this length space, 0 and 5, and I made just 100 data points, right? So press this, and I still didn't let run, so it still didn't run. And the second thing, let's write this equation in y. X minus 3. And then, because this is vector, so I'll just make it like element wise. Square and then plus 10. Okay. And then let's run these ones. Okay, they run fine. We can actually, so here I just made the made this compound expression, right, for the equation. Basically, I can maybe start to plot. So the plotting, you can just put the x and then put the y, and that is enough. Came on the other screen, so here it is. So this is x, this is y, and this is our function, right? So the maximum, yeah, so if I want to find the maximum of y, the maximum of y basically more or less around 10. How now to get it, but I want just to spend a bit time on the figures. If you look here, it's a bit continuous, but actually what we have, we only have 100 points. And if I want to make them apparent, use something like this, and there's a star. The star basically, let's see, turn to the background. So yeah, here just put a star at the 100 data points that we have. Make this bigger, you will see more spaces between them. I don't have a continuous function, I just have some data points and I'm just plotting them. Of course, you can do all of stuff about plots. So, for example, there are colors and stuff. And I think there's a table that's really handy. CLC, and I see help plot. This plot. Here you can choose colors, the left column, and the middle is like the data points. That should be a point, circle, X, and this is the continuous line that basically connect the data points. For example, we can make something maybe a star and then make blue and make maybe, I don't know, dashed maybe. So dash is like this. I have to just get it from here. So if the star is not so fun, maybe you can make it like a dot, something like that. Maybe a O. Just getting it from here. Oops. So here you have the data points as a circle and you connect them by a dotted line. And it doesn't matter the order, so you can put the, I don't know, the dash first and then the E and then the O. It doesn't matter, so this also works. Okay. One thing also we wanted to do is like to get the maximum, right? So of course we have function for that. So the y is basically the vector has 100 numbers. So the way to get the maximum is just use this function called max. You just put max y and give you the maximum. It's around 10. Let's try to have multiple versions of y and maybe make them on the same plot. So we have maybe this is y1. Maybe make y2. Just copy this one twice. So let's make this 5. So this is y2. This is y3. Let's make the change here. Okay, so now I have basically 3 functions. Run them. And let's see how to plot them. So you can basically open a figure. 1 plot x against y1. Copy this. y2, y3. Make this, I don't know, magenta. Let's make this black. Dot. Let's think a square. Let's make this, I don't know, dot. Let's make like, forgot the other one, maybe. I think it was something like dot, just like this. Dot this. And okay, when you think about it, like, okay, it didn't plot all the three. And the reason is the last one overrides the previous two. So you need this kind of hold on. I think I messed up with this one. Let's make it without. Yeah, I got them here. These are the three dots. Okay, I'll come back to it later. Yeah. What I also wanted to talk about, talked about the maximum. Of course, you can take the minimum. CLC, of course, you can take the minimum, which is basically 1. You can search for functions here. So, for example, let's say max. I tell you kind of function with max inside of it. Yeah, so to return the maximum value, basically. I think you can also, I don't know, integral, integrate, all this kind of stuff. Yeah. Okay. So again, at the beginning, we just need to know the basics, right? We don't need to know every function by heart. We need to know just how to find info. And basically, you can use Google. You can, of course, use ChatGPT, maybe just to tip you to really give the solution. How to find the approach on a problem and so on. Okay. So here I wanted to get, the problem wanted actually kind of three things. One was to get the maximum, the minimum, both, and then we needed to get what is function value when x is 20.7. So this is when the x is 20.7. Let's make it like at, because maybe you may make it like an index, not an index. So what's y when x equal 20.7? Yeah. So maybe we actually don't have a 20.7 in our x's in the length space. So how to approach this problem? So of course the easy way is, okay, make x equal 20.7, right? And just substitute it, right? So I can make like this. It's the original function, and I can run these two lines, right? That's the idea. But every time now I want to have a different value of x, I will just need to swap it, right? But there's a nicer way is to make a function, MATLAB function out of this algebraic function. Yeah. And the way is called, they call it like, you can make something called anonymous function. So basically, you can say y is make this kind of at. This kind of to prompt MATLAB that this is a function, and you can put the parameter inside, and then you write your own function. So here we have this negative x minus 3 square, and then plus 10. You can wrap it in a parentheses just to make it clean, but it will not matter. Okay. So now when you define it, it returns like a function handle and so on. This basically means that now you can substitute. Now it becomes y as a function of x, and you can, instead of this x, put a number. So 20.7, for example, and then returns the answer. And of course, you can use put other numbers and so on. Okay, I forgot to say something about the maximum and the minimum. So I may need, for example, here what's the maximum and minimum of y, but I may need also what is the x at this maximum. So if I have the figure, so let's remove this. Let's make this. Yeah. Let's make just the first one. Basically, what he's asking is like he wants a 3. So now you know the maximum is 10. He wants a 3. And so now how to do that? And the way to do it, also this function maximum. We know if I got the maximum of y, it returns the. Sorry, it should be y1. It returns me the maximum of y. But what if I want the index? So the address of this value in the vector of y1. And the way to do it is if we, for example, press help max, just know how. Tells you many things, of course, but one thing here. The first one returned the value, and the second one returned the index. So that means it depends how much output I get from it. So let's make like this is m. So this is the maximum value, and this is the index of the maximum value. And then I call this is maximum y. Yeah, this is y1. So here it returns me the maximum value and returns the index. So now if I got this index, if I go to y1 and I basically search for the 60, it should return the same number, right? So that means I can also use it to get the x in front of it. So if I put like x of 60, so then I have it. Yeah. So if I want to make it in a few lines, let's take this, copy, and put it here, and just say so x, I don't know, add y max. So equal x of whatever this one, and you can press tab to autocomplete. And that's basically it. Yeah. You can also do it for the minimum. Okay. Now I want to again speak about the figures. So we had this. Let's delete everything here. Start fresh. So we have can start with CLC, clear variables, to clear all the variables in the workspace. And basically then we have our X. So 0 and 5 is 100 values. Then you have the Y. Then you have 10. Okay, and then press this, say let's plot X and Y. Sometimes when you press also right arrow, it auto completes, and the way to run from it is, I think, to go up, just to go up away from it. Then you can just basically read F5. So again, this is our figure. And now, but this figure is without, yeah, it doesn't have a label, X label, doesn't have a Y label, doesn't have a title. And so we can start adding these things. So we can put a label, tab, and you can have the X here, same for the Y label. And you can have the title, Y versus X. You can have also can have a grid on it. So now if we run this, so now we have the X, we have the Y, the X, and the title. Okay. Let's return to having again like 3 plots, right? So let's say, okay, I have again, I want to show you something. So I have a second version of this. Let's set this one, this is 2. So this is y2, y3. Let's make this 5, and let's make this t. Yeah, and as we said, we can you can have them on the same plot. So you have X on Y1, then you hold on, and then you plot the others. The same X. Yeah. Let's run this. So I have the 3, and he gives them automatically like different colors. But now we have 3, and now it makes sense actually to differentiate that one of them is y1, one is y2, one is y3. And this is basically the purpose of the legend. Yeah. So we can just call legend. And the legend basically takes, if you plotted first y1, then you put y1 first. Then you put y2, then y3. I think it should be perfect. Let's see. So, and here it is. Yeah, y1, y2, and I3. Now you can differentiate between them. I also wanted maybe talk a bit about the figure. So here you have some tools. This pen basically makes you move a bit to the left, a bit to the right, you know. You can basically zoom on a certain area, right? You can press this home just to go to the main view. Zoom out. You can also basically pick a value. So let's, for example, so if I pressed this, quality inspector, I don't want this, so I can make a second. I open it. Okay, this. Yeah, with this data tips. So basically, you can mark certain values their x's. Yeah. I think if you press Alt, Control, I forgot actually. Ah, Shift. Okay. So with the Shift, you can basically keep them. Yeah. Of course, you can have all type of tools to save them. You can save them here. Save them as figure or as a different formats for a picture, PDFs, PNG, JPG. But one important thing is actually to make this higher quality image is to go to this export setup. You go to this rendering, and for the resolution, it's DPI. You can make it 600, especially if you have a publication or your thesis or something, so that the doesn't appear low resolution when you put it in a file. Okay. Okay, let's play a bit with figures again. Maybe I do this first. Okay. Let's go back to home. Okay. Wanted to do what? So yeah, if I want to impose certain x's, so I'm seeing now from 0 to 5, I want to see, for example, from 2 to 4, yeah, in the x. And this is done by this x limit. And this is done, you can say like xlim, and you have 2 to 4. If I press again, so then I get the limit 2 to 4. The same thing I can do for the y. And you give it in a form like a vector. The first point is x0 and the second point is x end, kind of x start and x end. Okay, I'll go back again to the figures. So we have, let's start from here. Let's say I want to have them, these ones on 3 separate figures, right? Let's say I have figure 1, Of course, you can, if you don't make hold on, they will go, but if you want to basically kind of choose X and Y one, X and Y three. And if we press this, we will have three different figures. So this is from the beginning. So one thing also to actually can use this kind of close all. This is to close all the figures. So I have here like two figures like this, and the first one got one of these got X and Y one again on it. And if I press F5, they get closed and a new one comes. So the first one, second one, and third one. Yeah. Okay. But there is actually maybe a handy way to put them all in one instead of having like different dialog boxes like this. So basically, you can make a matrix of a figure so that you can put the three plots in the same figure. Like so you have plots. So this is a figure box, and then you have a plot. So basically, it makes sense that you can make a matrix of plots, like three. Make the figure, make it like three spaces for the three plots. Let's see how. Let's see. Yeah. So this is basically done through this something called subplot. So we have subplot. So basically, you can break down your figures. So you say I want actually make them in one row. So I have one row, three columns, and this next figure will take the first position like this. So you can write it like this, or write it like this. Doesn't matter. So the second one will take the second position. So I will keep everything. And you just make here the figure one. And here, what make this two? This is basically three. If I wrote F5, so you have something like this. Of course, for each, it needs its own, for each plot, needs its own like labels, X label, Y label, title, and so on. But yeah, that looks much better than just three separate figures. Okay. Okay, let's go to another. We have just a few left. Second example. The example is let's my okay. Let's keep this. Second example is that to get the percent of y values that are greater than 0.8 for x between 0 and 10 to the function y equals sine of x. So so the function sign goes from -1 to 1, and here you will basically generate some points between 0 and 10 for the x, and basically count how many of these values are above 0.8. And then after you count, you just get the percent. Of course, it has an analytical way, but I'm just doing a simulation right now. So again, the first way is generating a length space in 0 and 10. Let's make 1,000 points. With more points. The y is basically sine of x. Maybe let's plot them first. So you have x, y, and then make the marker dot blue, whatever. Okay, and you can basically hold on. You can write also kind of plot, kind of horizontal line. So let's make this first, and then I show you what I mean. Run F5. So this is basically our sine wave. So -1 to 1 on the range from 0 to 10. And now we want how many values cross this 0.8. And now we can make just a horizontal line to mark this line, this region. Basically, you make plots, give it two vectors. Basically, this has the axis, so x1 and x2, and then this has y1, y2. So here we want, if you go back here, we want the, so a line is 2 points, right? So we can make a point here. We can make a point here. So the first point at 0 and 0.8. So this is 0, and this is 0.8. And the one, it's the same 0.8 as well. It's a horizontal line. And the x is basically the end of the region, so the 10 right here. So if I run this now, so we have this kind of line here. So now we want to count all these values that are above 0.8. How many are they? And take the percent of all the points. Okay, so how to do this now? This will make us go to the logic part. The logic part. So basically, let's say I have, let's use I have z equal 10, for example. And I can ask something like, is z less than 100? And let's see MATLAB, what does it say? And these two. So yeah, z is 10, and z is less than 100, and it gives us a logical one. That means true. Yeah. But if, for example, if it's less than 1, run it again, give us logical 0. That means false. And not only that, you can actually apply it for a whole vector. So if x is z is like numbers from 1 to 10, and you can say what are the values is greater than maybe 5. Run this one. 5%, yeah. So it gives us here the first 5 numbers is 0, but starting from 6 until 10, you give us 1. And basically, you can get what are these values that are 1s, what are these values that less than 0. So you can say, okay, print for me, move it like this. use kind of indexing, but through the logic output. So give me the z values greater than 5. Run this one. So give us 6, 7, 8, 9, and 10. Do the same. Give me the z values less than 5. Run it. I select and I press F9. Give me the first 4 numbers. Okay. And also there is a function called sum that I want to see. So for example, let's go back again here. What are the values less than 5? Give you basically this. So I can count these ones. How many are they? There are 4. So if I use sum, make it in the terminal. So if I use sum z less than 5, I expect 4. Yeah, and I got 4. I have 4 numbers less than 5, and I got their number from sum. So basically, it summed all these, and these are zeros. So yeah, makes sense, hopefully. Also for the logic, I can combine different logic. So let's say I want the numbers greater than 5, but maybe less than 8. So I used here this AND. Yeah. So if I run it alone, that should give me yeah, between 6 and 7 only. So you'll see here 6 and 7 are ones, and if I to be sure, I can put Z and I index it with the whole thing here. It gave me 6 and 7. Okay. I can also use another logic. You can use, for example, say there are the values that equals to 5. So it is double equals, not one equal, is double equal. Then it's like you are searching. Compare every element in the vector to 5 and tell me which one it is. So here I expect all zeros expect 5. That's 1. Okay. There's also not 5. Not 5 is delta. Sometimes I don't find this one. Maybe this. Nope. Let's think this. Yeah. This tilde. So I have it on my German keyboard on the left. At the asterisk plus delta, and I use the algebra with it to get it. And this one I expect not 5, so it means that all these numbers that was zeros becomes 1, and this one becomes 0. So it becomes the opposite. Yeah. Okay. There is also, instead of and, there is or. So I can get the values, let's say, less than 3. There is or, and or is basically like this line. It's, for me, is near the left shift, and greater than 8. This number should be 1, 2, 9, and 10, right? This or this. So 1, 2, and 9, and 10. And I use indexing, that's why the numbers came out. So I move the Z, it returns back again 1 and zeros. Yeah. Okay. Please, this is enough for that part. And I think now I can go back to the problem. Right now we know how to deal with it. So I have the x's, I have the y's. And now I can ask to give me the values greater than 0.8. So y greater than 1.8, that will give me all the values. The values are greater than 0.8 will have this logical 1, and others become 0. Okay, so let's see, this is maybe the indices of wanted y's. Yeah, I save it here. Okay, I'll make it like I collapse it so that it doesn't fill my command window. And then maybe let's sum them. How many are they? I can use tab, autocomplete. So if I ran this one, let's see what it will give me. So yeah, 257 numbers out of the 1,000. So then I can easily get the percent by dividing. So I can divide by 1,000, but if this 1,000 is a parameter, how to always get it? So there is something called you can get the length of x. So that basically how many columns. There is something called width of x. This is the same. And now there is height of x. Basically, this give you measure how many rows. And you can also use like size of x. That give you two numbers, so you can maybe make it like this. Say n columns, n rows. That's the size of x. So now you have the. I think I got it wrong. Sorry. Swap. So I think you got what I mean. So this is n rows. This is n columns. So here the n of rows 1 and 1,000. I can use this one. So yeah, whatever. If I use a length, and you multiply by 100 for the percent, and that's how you get 5, and then you have 25%. And for example, if I decrease this number, you can find this number is different because now it's not really accurate. You have only 100 points to represent the sine wave. The more I increase, the more the number changes. So now I have, seems more full. I have 1,000. I have 25.7. Let's make it another 100. I have hundreds. 10,000. 5 bit different, right? And now you will, yeah, make another 100. I think this will stay like this. I'll change a bit. This is even more and more accurate, yeah, because I increase the number of points. Okay, this was a bit useful. Okay, what can we do? We can actually, okay, let's do this because now we have like we can, you see I change this one like multiple times. I can also make this, I don't know, 0.7, yeah. So I can have different questions, like same question but different parameters, you know. And so of course then I have to change this here, you know what I mean. So how to make this a bit more neat, and the way to do it is to define a function. And you can define a function not anonymous now, but with a name. So you can go, for example, to new, and you can say new function. Yeah, and then it gives you kind of a template. So you have the function, that's the name of it, and very important that its name is the same as the name of the file. Yeah. and here is the input arguments. And here describes the function, what does it do. And you can use now the arguments, the inputs, this and this, to calculate the outputs, and you give away the output. Okay. So let's maybe copy these here. So let's see, what do we want to do. I will just, yeah, maybe delete it once. Okay, so what do I need as input? Maybe the number of points. So let's say this is n points. I have n points, and yeah, maybe I don't want the 10. So let's say I want this also as an input, x end, like this. Just very fast, the way to name the variables, there's something called the camel casing. So like the camel and then case. So you have two words, you can get them together, but make the first one lowercase. It's kind of convention, there's no must, of course, or you can make it like camel case, like this. So it's underscoring. Sometimes I combine them, so there's no right or wrong about this thing, but yeah, just for convention, so that, yeah, other people can read your code, but yeah, you can see me also, I'm not always following it. But when you work with a big group, a team or something, then it's actually more useful. Okay, this is a fast comment. So now the inputs. I wanted this input, I wanted this an input. And here, yeah, this is the y limit kind of, right? This is the y minimum. So I want above it. Let's make it y threshold. More meaningful. So this is here and this is here. Okay. And this is also here. Okay. And okay. And this is 10, so this also should be x end. To make it all I think. Okay, now let's put the inputs here. So start with we have x end, endpoints. Probably the most important is y threshold, so we put it at the beginning. Right? And let's and what is the output? So the output is this percent, right? So we want this percent is the output. Doesn't matter this or this. Maybe yeah, we just give it here. It's y%, yeah, percent buff. Yep, it will warn me if I'm not using it. So now I'm using it. So same color. Seems fine. Okay, maybe I call it differently. Maybe I call it something like get y, get a percent above y. I don't know. Good to make it meaningful, at least to you, so that you kind of, yeah, remember what does it do. And here, nice thing, it gave me the default name of it, the one I wrote it here. I can save it, and I save it in the current folder. So this is where I can call it. So if I'm using a script and the script is not here, the function is not saved in the same folder, and I'm calling it from that folder, it will not be called through an error. So it has to be in the same folder like your script, main script. I saved it. So I'm in test2. And so now test2 and get percent above are in the same folder. And so I can call it. Let's see if it actually works. Try the same thing. So say y send, so get yeah, that it read it good. Then when I open, then it starts with what's the threshold, let's give the same 0.8, and the x end was 10, and the number of points was 100,000. I think also you can make it like the scientific notion. I think scientific notion will be 1e5. It will take it. And yeah, let's run only this line. I think I don't need anything else. Let's see. Okay, it gave it. It plotted the function, so it actually worked. Good. So that's how you kind of. And now here you can play with any of these numbers, and you don't need to go inside and change them. So it changes for itself. Yeah, it feed itself, and it give you what you wanted then. So that's how you wrap it in a function. Okay. I think we have 2 more examples, and then we will finish. So okay, let's check the second example. I will talk about the section. It's just a minute. Okay. I think this is similar to what I did, so I don't need to. Maybe let's do it. Yeah. Okay. The problem says generate, and I will upload these problems in the slides. Like the problem exercise, and I found really nice tutorial from one of our colleagues, Christoph, Dr. Christoph Fenders. He has a really nice tutorial. PDF. I will also send you guys this one if you want to check it. If this is like too slow for you or too basic, feel free to just look at the tutorial. So now we have generate 10 random values from 1 to 5. And I'm writing and count the number of threes. How many threes appears? So how many threes appeared? Yeah. So this is 1. Display. Yeah. Wow. If more than 20% of the generated numbers are threes. Yeah. And now we can do. This is kind of. There are 2 ways to do this, and this will be a problem just to introduce you for loop. Yeah, we have a problem to introduce for loop, and then we have a problem to introduce you while loop. Yeah. Okay. And then we do previous steps with a for loop. We'll do differently. Not with the for loop. We'll do it with the indexing, with the logic. And then compare the runtime for loop versus basically the array way kind of. Okay, so start. So the way to generate random numbers. Let's run this first. Run this. Here's a I want to talk to you a bit about the rand. So there is many functions, of course, that for the rand you can look up them, like here. Just write rand, and you'll find like many. But the one I'm here using is friend I. So this is basically generate random numbers between this 1 and 5. This is a maximum. So let's just see it. Yeah, so this is generate on, yeah, if I break again, if I need, this is your one on my maximum. Yeah, it's interesting. Give me 5 two times. Right, so it was a bit weird. Yeah, now give me 4. So there's something wrong because give me 5 two times around each other. But yeah, it generated numbers between 1 and 5, basically. Yeah, so every time I'm pressing F5 just to give different numbers. Now you can do that for populate an array with these numbers. So say like 10. So you have now 10 by 10 array populated with numbers, randomly generated numbers between 1 and 5. Also, not necessarily array, you can make it with like a row vector. So if I make this, so now I have 10 values generated, randomly generated between 1 and 5. Okay, I think there is a way, I'm not sure. I think is it like this? Check it, but if I made like, I don't know, from 100, will this work? Yeah, actually this works. Okay, so now if I want different start and end, so I don't want always to start from 1, I want to start from 50. So now I started from 50, I ended with 100. And yeah, and this is the number of, and these are the values generated between 50 and 100, and I have 10 elements. Yeah, okay, let's just move on. So what do we need? We need 10 random values from 1 to 5. So I don't need this. I'll just put 5. And then I need 10 random variables. So yeah, 1, 10, or 10, 1 doesn't matter. So I can make like this 10, 1. This will give you the column. It will give the column 1. Yeah, gives a column vector. Yeah, it doesn't matter. Okay, so this is basically, let's say this is y generated. Yeah, and then okay, how to count the number of trees. So we checked this before. So we say ygen give me the numbers equals 3. So if I run these together, let's run this. So how many trees I have here? Let's see, like see this first. So I have 1 and 2. So should give logical 1 at these ones only. Yeah, so give logical 1 here and here. Yeah. And okay, I can basically sum. How many are they? So 2, right? Then again, I can do the same. Length of A, or length of ygen. How many are they? Then you can get kind of the percent. How many are they? So 10%. Yeah, for example. So that means it appeared 1 time here. So yeah. Okay, and now we have this thing. If this percent is greater than 20%, we like we display this wow thing. Yeah. So we say, let's save this one. So percent, like percent found. Sometimes you just make this shortcuts. So percent found. So let's say you have the if now. This if condition, it takes a condition here. If this condition is true, it will, and it always has this kind of end. They go together. This is the start of the if, and this is the end. This has to be exist. If it doesn't exist, I think MATLAB will complain. Yeah? And if you just stand on it, so an end might be missing. Yeah? So sometimes this helps, and it takes it alone to the left. Anyhow, so now what's our condition? Our condition, if this percent found, I made tab, is greater than 20%. Just press tab inside to go inside. Then we display this wow thing. Yeah, display, make a text. Wow. So let's now see if that will work. So I will leave the percent so that I see. So it got 40 more than 20, so it displayed this wow thing. Yeah, and of course you can wrap this also as a function, but this was just introduce f, and now we introduce for. Now how to do this with for loop. This actually the one that we used. So we compared the whole generated y to 3, but actually we can actually check one by one. So now if you want to do it four-way, we'll talk about the sections. Four-way. So the four-way, how to do this one. So basically you for loop on it. Do for loops in Python and R. So okay. So for loop. So you write like this. Anyhow, even if I don't know it, I just I click and then press F1 and it will tell me how. Yeah. And jump directly to an example to see how they do it. Yeah, for C equal 1 to S and so on. Yeah. So it takes kind of an index. This is kind of call it like postman. It goes to every element of the array. For example, you have 10 elements that you want to go on, and it will have different values here. And then it has end. Basically, the for loop, you have kind of a certain code here, right? And this code will be run maximum this number of lines, maximum not this number of times, 10 times, yeah. So it goes from 1 to 10, and then at 11 it increments. So it runs the code once when I equal 1, and then it goes, it becomes I equal 2, and then run the same code, and then I equal 3, run the same code, and so on. Yeah. So okay. So how many elements we have? So we have 10. I can put 10 here, or the length of this. Yeah, it doesn't matter. Let's keep it like this, simple. And now what do I want to do? I want to compare each element in this ygen to 3. Yeah. So I say ygen, the element that it's turn. So I index it. So from 1 to 10. And I compare it. So is equal 3. Right? Like that, right? Yeah. So let's say I have something outside called like the n threes. How many threes got found? Yeah. So it starts with 0. I say, okay, if I found this one, this is true, because this will return true or not. Yeah. You are comparing one element to one element, so it will return true or false. So if this is true, I have to make it end. Then we say the n series, increase it by 1. So there is this plus equal 1. This means basically take the n series, add to them 1, and put it back in n series. Yeah. So, and as a short format, you can like this, right? Okay. Not sure why he's complaining. Yeah, I'm incrementing it. Complain. Okay. Actually, I'm interested to see what could happen. I think I moved something. Did I move something? Cannot. Interesting. Yeah. Select for some reason. Did I press insert? I'm just having this mouse. It helps closing open it again. Yeah, probably. Let's now run this. Interesting. Maybe it doesn't like this one. Yeah, it doesn't like this. Okay. Sorry, I just got this from the other one from Python and from R. So basically, it doesn't like this thing. Yeah. So yeah. Okay. What else? Okay. So I got the number of threes. It was 0, then it became 4. 4. Yeah, interesting. Yeah, it's 4. Okay. So it seems it's doing its job, right? And now we have the n series, and when we divide it by the length of the y-gen, multiply by 100, then we get the percent. So this is percent 4, using 4, yeah. If I run this, then it gives me the 40% that I got before, right? And again, I can write the same. If the percent found greater than 40, then so and so, yeah. Just copy this. I'll tell you why I'm doing it again. Yeah, doesn't matter this or that. Okay. So now this is the 4-way. If I run it, give me the wall. Okay. Now we have it. Now the for loop, it is notorious that it's slower, that you are going element by element, and now here they're using the kind of the matrix, the arrays way, which is known to be much faster. So the way we can actually measure the time. So how much does this take? How much does this take? And the way to do it is through something called the TikTok. Yeah, not TikTok, of course, but it's called like this. So it's tick. And this is talk. Hopefully I'm writing it right. Check it. Yes, exactly. Okay, and then I can say this is I put tick at the start of the code that I want to check how much time does it take, the elapsed time, and then I put the talk here, and at the talk here I can put it in a variable now. So I can call it t. Let's say t array talk. Yeah. And I have also the for way I can also measure it. So I have the tick again, and I have the talk. Talk is also, I call it t4. Call it talk. Yeah. So now I will display this. I will display this, and then yeah, let's see. Not sure I don't want to see this. I don't want to see this. Right. So now let's see. So the T4, so this is 4 numbers, so that means they persist 1. So they're very comparable, right? They're very, very comparable. But here, I think even they're very, very near. But what happens if we made the number bigger? So now this 10 becomes a bigger number. So let's make it, so endpoints, so let's make it 1000, yeah? Let's make sure we put them where it needs to be. So this is 10 here. This is right. And now for the for loop, it has to be here. Right? And then yeah. Okay. Let's start again. Wow. So you can see now I think this one is much less than the T4. And so 3, and then you have 3, so it will come here. So it has 3 zeros, and this has only 2. That means this is like almost twice faster. And the fastness even increases the number of points. So now if I have, I don't know, 100,000, yeah? So I think now it's here. Let's make it a million. Interesting. I need to check this. It's interesting that is T4 here is actually faster. I think something else happened. I'll check this and maybe let you know. It's interesting. Yeah, I don't know. I need to check this. Oh, cool. It's interesting. Okay, I got something interesting. Anyhow, so we check the for loop, the if, and the TikTok timing of the functions. And we did it through also the array way. Okay. I want now to let's talk about the sections. So sections is basically a way to divide your code into multiple parts that you can run them kind of independently. So you use 2 semicolons. So now you have one section. And then maybe we separate it at here, at the 4-way. So the 4-way here, let's make it like this. So this is a 4-way. Let's call this array way or something. Okay. And then to run them, can use, I think, so if you're inside now this section, if you press Control plus Enter, you run the first section until here. So here we have the T array, here it is. And now if you, I think you press, if you go here and you press again Control Enter, you run the 4 section, the 4-way section, right? You can also use it here. So there's here run section. You can use it from here, and you can yeah, run an advance. So he goes to the second one, and then you run an advance. So yeah, hopefully this is useful. Okay. The thing basically it goes kind of line by line this step. Yeah, so you can use like F10 kind of. Okay. Yeah, I just want to say something about maybe the naming of the variables. So basically, you cannot start the variable with a number, so you can like 1x like this. This works. Yeah, I need to just give the number. You cannot start with kind of a simple asterisk, question mark, whatever. Better to avoid certain built-in names. So sum is a function, right? So I can some x, right? Was it ygen? Yeah, I can sum ygen, right? But it's better not to use it as a sum. Then it becomes really so it's better not to use a reserved built-in names for the functions or things like that. Yeah, so that's basically it. This is the thing. Okay. I want to introduce the while loop. I think I said many things. Yeah, the while loop, and then we have the last example. Then we end. Okay. So let's now talk about the while loop. Make a this. Let's take this and delete it. Now the while loop. So the while loop basically it's like the for loop in a sense. It also needs a condition. And then you have there's this end part, and then you write some code inside, right? And that code keeps running. There's no indexing now, but there's a condition that as long as it is true, you are inside. But if you if that condition becomes false, then the while loop stops. And this is really important because while loop can really stuck your PC in a infinite loop, and if you really don't think about it, then it will consume resources, make it stuck and freeze. Yeah. Okay. Let's get an example. For example, let's say I have x. Let's first see this. Okay. Let's say I start with z equal 100 or something. And I say let's say I'll say it's z less than, let's say if z, while z is less than or greater than 0, display z. And I don't do anything. That doesn't make a problem. So here it checks take z 100 greater than 0, yes, then it does this one and then goes back again. Is z less still greater than 0? Yes, so it does this again. So if I run this one, it will make my computer stuck. So I'll just show it very fast and then kind of cut it out. So if I press, then it print, and then I made Control C just to break it. So here Z needs to be decreased, right? Otherwise it will keep going. So here you need something like the increments of to decrease it, and to do it again. So here just stop. Yeah, so it went until the 1 and then stopped. Okay. Okay. Then I think we can go to the example, and this really nice example. It has to do with prime, using the prime, checking if a number is prime number or not. So prime number basically can only divide on itself or 1, so it cannot be divided by anything else. Let's so we wanna generate some random values. Sorry. So we have we generate random values. So let's make it try to write it. Generate random values. How many? Maybe I don't know, say 50, from 1 to 100, and check if they are prime, or count. So let's say count how many are prime. Okay. And then compare it with built-in function called isPrime. So isPrime is a function in MATLAB that you can it checks. Sorry, I pressed wrong. So basically, it returns if you give it like some values, it returns you which one are prime. Yeah, and we wanna make a custom function and compare the performance of both, also using TikTok. So then, how to make a prime number? How to make a prime number checker? Okay, so let's first generate the random values. So I have matrix A, and I have random variables, and I want maximum 100. So I start with 1. I want 50 values, so let's say a row vector 150. Okay, like before, and let's and then I will do it the way we'll do it is that we'll go through a for loop, each one of these elements, and I check if it is prime, right? Okay, so I go for loop from 1, and so this is indexing. So until the length, give me this one, length of A. So all A. Let's put the end. I want to check Then there are certain cases. If it happened, then I don't need to check more. So if the number is, I don't know, 1 or less, then I don't need to check if it's prime number or not, right? It is yeah. So let's say, so if AI less than or equal 1, so if this is 1, yeah, basically continue. Yeah, that means I will just go to the next iteration. Need the end. Okay, and then if not, now I need to check if it's prime or not. And the way to check it is to check the numbers from 2 until the square root of that number, to check if it is divisible by them or not. So I can go from k, for example, from 2 until the square root of e. Let me put the end, and then now I need to check, is this divisible or not? So divisible is basically is a function that called mod. So this mod basically check if there is a remainder in the division. So if you have 9, say, is it divisible by 3? It is divisible if the remainder is 0. So if you put it, remainder here is 0, that is divisible. So, but this is 4, then yeah, so there is a remainder of 1. So then it's not divisible. So we need to check this condition. So I need to check if mod, oops. Basically, if you did this, you can continue here, by the way. It's the 3 dots means that you can, sometimes you are at the end of this line, and if you press this one, shift enter, you can go to the second line and MATLAB just continue reading. So yeah, let's go to there. So mod AI, then K, yes. Okay, let's make it clear first. So if this is 0, that means so no remainder means divisible, so it's not prime, right? So this is not prime. So yeah. If it's divisible, that means not prime. So not prime, that means yeah, this is now we need a way to basically tell that this one is not prime. We can make something like result, maybe. Then I can start with the assumption that it's true. This guy is Um, but if this happens, then this is not a prime, and basically break. Break from this. So break basically, you don't need to continue the for loop. So it takes you outside of the for loop. So it doesn't take, it's not takes you out from if, takes you out from the for loop, and takes you out from the while loop. So that you don't need to continue the iterations. I don't need to look anymore. I know it's divisible, so I don't, it's not prime. Okay. So this is the first one, and then I can just put another. Did I put an int for this? This one? This is it says one down. Okay. Change this one. Okay, now it's good. So actually, I need to go outside of this. Done. So if the result is still true, so I didn't get this false thing from here. I started with true, and I passed peacefully through this one, and this was never zero. This mode, this division, the remainder was never zero, so I stayed with true. So that means this is prime. Here, not prime. I need another int. Okay, if that happens, then let's display it. Plus that number. Remember, I have course. I'm looping over them one by one. Every time I enter here, I have this a of I. This is a number. I'm checking, is this prime or not? Okay, so now I reach the conclusion that this guy is prime. So I display it, and maybe also I save it so that we know how many primes we have. Or maybe make a counter. I don't need to save it. So let's make counter like n primes. In primes, I start with 0, and maybe also I want to show you something. So if I want to save them, let's say I want to save them, I can have an array. Sorry, this is empty array, like empty vector, right? Before we had this 2, 3, 4 inside. Now I'm just saying, you have an empty empty array, right? And I will tell you what to do with it. So if this is prime, then the number increases by 1. So n primes equal n primes plus 1. Let's see. And I want to save this prime number. So the prime number is a of I, right? So I say, okay, how to add now a value to the array. So the way is you extend the array. So let's say something. Before I do here, let's say v equal 1, 2, and 3. And let's say I want to add 4 to it. So the way to add 4 to it is to say v equal, and say you put v again, the 1, 2, 3, and then you put 4. So you got the 3 numbers, you added 4, then you have the 4 numbers, yeah? So then here I do say primes, and I add another one. Which one? A of I. This is a new prime that I found. So even with this empty, this will be the first number in the vector. Yeah. Okay. I make like this. And here he will complain that the vector will change its size. But of course, I cannot know before how many primes I will have, right? So I need to increase the array dynamically. It depends upon the numbers that I get randomly. Okay. Then good. Okay. So I think let's try. So and let's type these primes, see the values that we have, and let's check it with the inbuilt-in function. So is prime. So is prime takes a and it return the logical values. And so then we can say, okay, take these logical values and tell me now what are these numbers that you found that are prime. So let's to show it. So I defined this one. This is a. So this is basically how many? Like 50 values, right? If I open it here, I have 50 values randomly generated, right? Then I can say, okay, I use a built-in function. Tell me which one of these are prime. Give you logical. Then I can, okay, I want to know what are these values that you found prime. So you say is prime, and then a, and it tell you what are these values. And now we can compare these values with the values that we got from our function, this custom function. Yeah. Okay, so we have primes and then if primes, and we see if they are the same, then it works. If not, then we have a problem. Okay, let's see. So it looks the same. Yeah, looks the same. Okay, so it let's try again. Yeah, I'm pressing F5. So I'm running the whole script again. So it looks good, right? Okay. Of course I can count how many are prime. I already have the m primes, right? And I can display maybe the percent. How many are they? So length of a. Or of course you have primes, and you can take the length of it. So I don't need the counter if I have primes. Yeah. Let's see the percent. Yeah. So we have 20%, 6%. Yeah. So of course we can increase the number. Yeah. Anyhow. So what I want to do now is just to again check the performance of this one compared to S prime. Okay, so I want to have here primes. So how to do it? So let's say make a section. Say this is custom. Ooh, sticky thing. My caps lock got interestingly. Yeah, okay. I don't know what happened, but my caps lock was really sick. Yeah, so we're back. So now this is custom prime checker, and let's say we have here the built-in prime checker, and okay, and it's basically this guy. Yeah. So, oops, this. Okay, and let me take this up so both can see it. And let's again make this TikTok stuff. So take this elapse built-in talk. Built-in. Display it, and then you have here, maybe from here, tick. Doesn't matter. Doesn't matter. Tick. Then you need this. So let's say just save it here. Result 1. Result 2. Doesn't matter here. You make the talk T custom talk. Okay. I want it to appear, and then let us let's run it. See. T custom. I think I made it above. Yeah, let's make it here. Let's make it T build. Yeah. So the built-in is faster. So that's also the idea here is the message is that when there is a built-in function for something, you probably don't need to do it. So you just use them out of the box from the library, and there is a major like a big libraries of functions. In MATLAB, you just need to search. So it's better first to look for a function that does what you want before you do it yourself. That's probably just a message. And yeah, I think I don't have anything else. Yeah, hopefully that was useful. And yeah, thanks for. I actually learned. It was good actually for me to because I use Python and R. So I don't use actually MATLAB much. So it was good for me actually to go through all this stuff. And yeah, so thank you, and yeah, see you in class.